So in this situation, again, it's a miniature harbor type of thing. I don't know if any of you have encountered or worked with this kind of stuff. So it's like, particularly for these container ships, but certainly for anything where a ship has stuff to be unloaded, you will typically have cranes that kind of pull them off the ship. And particularly for, one of the reasons why container ships are so prevalent is that it's fairly straightforward. It just kind of, it's basically like a big stack of blocks, so it's much more straightforward than weirdly shaped things. So the idea is that in this little area that you have two cranes and two berths for the ships. And obviously, if you have a ship in each berth, then one crane unloads one and the other crane unloads the other. But the little twist here is that if there's only one ship, it turns out that the cranes are configured so that both of them can unload them at the same time. And this is where the assumption is probably a little bit optimistic. So the idea is that if both cranes are unloading it, then you'll get done in half the time. Now, will it be half the time, literally? Again, maybe. It certainly probably won't be any quicker than half the time. It's probably going to be a little bit less. We'll start with half, just see how that goes. And that should be fairly intuitive. In other words, if two, it's like if you have two guys working on a task at the same rate, then they're going to get it, assuming they don't get in each other's way, you're going to finish it in half the time. Now here's where the event modeling gets a little tricky. So let's say the first ship is going to show up, and with the first ship, there's just going to be one of them. And so both of the cranes are going to be unloading it at twice the speed. But then if another ship shows up while you're doing that, then what happens is one of the cranes will stop unloading the first ship and start unloading the second ship. So that'll have two impacts. One is that the first ship has been worked on for a certain amount of time at twice the normal rate. And then there's still more work to be done, but from that point forward, it's only being done at a unit rate. In other words, the remaining unloading time is going to be increased basically by a factor of 2. Okay, so now and obviously if there are only 2 berths and a ship kind of comes in and they're both busy, then we have a queue. Then what happens when it finishes unloading? So if a ship finishes unloading, when there are 2 of them present, then if there's another ship waiting, then it kind of comes in and starts unloading. And again, as with our multiple server queue, we're gonna kind of assume that the time that takes is negligible. Again, that's another assumption that needs to be looked into. But in terms of the basic modeling issues that this presents, that is something that would come with another version of the model. But on the other hand, if you have 2 ships and each is being unloaded at unit rate, and then one of them finishes and leaves, then there's no other ship in the queue, then what can happen is the other crane that was just unloading the second ship, then switch back to unloading the first ship, and then again decreasing the remaining unloading time by half. So you see, so in a given cycle, you could have the ship being unloaded at one rate for a while, and then at another rate for another period of time, and then possibly at another rate for a third. And there's no theoretical limit to the number of times that the rate of unloading is going to change. So pictorially, it looks something like this. So in top is the situation where both berths are busy, and so this crane is unloading this guy, this crane is unloading this guy, and then in this particular case we have 2 in the queue. So the work is being done at normal rate. But if we only have 1 berth that's busy, nobody in the queue, nobody in the second one, then the idea is that both of these cranes are working at twice the normal rate. Okay. So is it clear what the issue, what the situation is? And a first cut at this model might be, say, a multiple server queue with where the cranes and the berths are kind of the servers. And so a first cut might just be our regular multiple server queue. Okay, and that's probably, I mean, if I were faced with this, that's the first thing I would do, because that's a model that's already in hand, and we could at least get kind of a ballpark estimate on how things are going. However, we would then do an audit, as it were, on that model, and we would see that what it's not taking into account is the fact that sometimes there are situations where the ships are being unloaded faster at a normal rate, and other times when it's just being done at the unit rate. In other words, if it were always the case that the cranes just kind of unloaded whatever ship was in front of them, then a multiple server queue would be a reasonable model. But in the situation here where we kind of work at twice the speed, then it's not a reasonable model, or just in the sense that the multiple server queue, just plain old multiple server queue, does not capture this this working at twice the speed, nor does it capture the fact that you have to kind of switch when if another ship comes in. Okay, so now how do we model that? Okay, the starting point would be we need to take into account the fact that each ship is going to have a remaining unloading time. And this is kind of similar to the model that we looked at yesterday, where the jobs had a certain amount of remaining time, and they would only be worked on a little bit by the CPU. Again, there was a problem with the disconnect between the event graph and the code yesterday, and again that'll be fixed. But hopefully, this idea was which is actually sort of common. So there's going to be a remaining unloading time, which is going to be initialized to however much the ship needs. Again, if it's a container ship, that's probably related to the number of containers that have to be unloaded. I mean, that, you know, what is it that causes the unloading time to be a certain amount? Well, again, if we're unloading containers, it's going to be how many containers you have. Just like in the supermarket, how long does it take to check out? That's probably some function of how many items you have. Okay, so we need a getter on that. But then corresponding to what we did yesterday, we're going to need to have the possibility that we're going to work at different rates. And so the idea is that we're going to expect that the event graph is going to stamp the times at particular events when it starts working at a particular rate. And so when that changes, when that shifts, then we need to credit the work. So work is actually crediting the work that has been done when there has to be a switch. And the switch can be either from working at twice the speed to working at 1 times the speed, or working at 1 times the speed to twice the speed. And then by just kind of making the rate an argument, that also leaves the possibility open that sometime down the line, if we did a time study on this, Supposing it turned out that instead of working at twice the rate when there are two cranes, it's only 1.5 times the rate. I mean, arguably, you would obviously be faster, but if it turns out that it's, say, 1.5 instead of 2, that the ship can handle that, because that's an argument. You know, in the component, we're gonna put the 2 in there, and that's something that one could argue could or perhaps should be a parameter. Okay, so, but again, this idea that we have a ship, and it's going to add these bits to it. Now, this should be fairly familiar to you by now. So again, we're going to separate the arrival of the ships from the berths. And so we would have like a ship arrival process. So this would be the first way of looking at it. And this should be very familiar by now. Again, we have our arrival process little piece there. And the arrival event is going to instantiate a new ship. We have as its parameters the ship unloading times. So we instantiate the ship and we tell it, this is how much unloading time you have. Again, this is going to be a parameter. Again, where does this come from? This would come from, if we're doing the study for an actual location, we would have to find out, you know, do some data analysis on, well, how long do these things take, you know, and how can we come up with a probability distribution that would represent, you know, how long it takes. And then we're going to schedule a ship arrival event. Okay, so this should, again, be fairly familiar to you. And then what's also familiar, or should be familiar, is the idea that since we have our arrival process, and again, like whenever you see something like this, then the possibility of being lazy and just kind of taking our arrival process that we already have in hand and then subclassing it and saying, okay, now we're just going to override the arrival event. In this case, you know, making sure we call the superclass arrival event, instantiate our ship, pass it as an argument to ship arrival. So again, we've seen many different instances of this pattern, and as a pattern of a situation where there is an infinite calling population, as we said, this is a reasonable way to represent it. In the case where there's a finite calling population, this isn't a reasonable way to represent it. We've seen several examples of that. Yesterday's was one example where we had a finite number of jobs. In the machine repair example, where the machines would work for a while and then fail, that's another example of a finite calling population, because we only have finitely many machines. And when they've all failed, then there aren't any more that arrive. So you have to be a little careful of that. I mean, I've seen some models where they have modeled a situation where there's clearly a finite number of these with a process like this, and sometimes you wind up with more items in the system than actually exist anywhere. I mean, just kind of as an extreme example, I mean, supposing we're dealing with carriers, well, I mean, or US carriers, well, there are, what, 11 of them? And so if I have 3 of them that are down for maintenance, then there are only, you know, going to be 8 potential ones that I have. And that's not even counting the fact that they're going to be in different parts of the world and doing different things. So, which just decreases it even more. So the point is if you're dealing with small numbers of potential, quote, customers, then you need to have a finite calling population model. Whereas it's important to recognize that as soon as you have this kind of pattern in your arrivals, then you're implicitly assuming an infinite population. And that's not a bad assumption when you have a whole lot of them. Okay, so now the event graph component itself is, okay, so here it is in all of its glory. So it looks fairly complicated, but let's just kind of break it down. Again, the state variables that we have are that, what are we interested in? Well, in terms of making the model run, there are basically two. Okay, one is we need a FIFO queue of the ships. And then here, well, I'm going to model it as another container that has the occupied berths, and it's going to initially be empty. And I'm going to call that B for berth. And so it's also going to contain ships, except there are only going to be two of them. So even though it's going to be a container, it's only going to we need to make sure that it only has at most two. We can have 0, 1, or 2. Those are the only possibilities. Obviously, an array would be the safest way to do that, but that leads to some just some complications in terms of identifying which one is going on. So I found it to be a little, actually a little more convenient to just make it be a list. So these are the only two state variables that we need, oops, to make the model run. These two are actually have to do with the kind of measures that we are interested in as far as the system goes. That is, what is the delay in the queue? That is, how long do the ships sit around waiting to be unloaded? And how much time do they spend in the system? Now, normally, actually, if you think about it, the time in this in every queuing situation, and this is a queue, there are typically two pieces to the time in the system. There's the time in the queue, and then there's the time, the processing. So in every queuing situation, that is the case. And so actually, the expected value of our waiting time, if you look at that, it would be the expected time in the queue, which I'm calling D for delay, plus the expected processing time, which we've been calling, say, T sub S up to now. Here we're calling it something else. And the thing is that if this is a distribution, that is, if say this were a gamma with a given mean, then we actually know what that is. And so this, if all we know is the expected delay in queue plus the expected time in processing, which this is going to be a number. So like if this were exponential with a mean of 3, then the expected value is 3. Just we know what that is. And so, I mean, it actually turns out that this is actually a smaller estimate than a lower variance estimate. This is a lower variance estimate than just doing the whole thing from scratch like this. However, in this case, that doesn't quite work, because our expected processing time is not just how much time we have to unload, but it's also a function of how much time was spent at a rate of 1 and how much time was spent at a rate of 2. And that's different. So we can't do that. And actually, so for this, again, we don't need these variables to run the system, but it would be very useful to have these so that we can actually compute them. Okay, so now let's look at what is in terms of the key state variables. These are the key ones that are going to drive how we define our events. So if we have secondary ones that we're interested in, I mean, obviously we need to make sure we count for those, but focus on the ones that kind of are crucial for for figuring out how the system works. Like, and the key to that is recognizing that delay in queue and time in system are never, we're never going to have to sort of test for these. These are never going to be edge conditions. These are just going to be things that we happen to be able to calculate. Okay, so let's start with Q and look at all the ways in which we that could be changed. The first is obviously an arrival. So if we have an arrival of this ship, then we want to stamp its time and add it to our queue. Now, what else could cause it? Well, here's an event. I'm going to call it start unloading with 2 cranes. And I'm not going to worry about the scheduling edges just yet. When I say if I start unloading on 2 cranes, then I pop a ship off the queue. I stamp its time. And actually, before I stamp its time, I get its elapsed time from for the delay in queue. So between the arrival and start unloading with 1 crane, when it arrived, I stamped the time. The elapsed time, therefore, is the delay in the queue for this, if I start unloading with 2 cranes. Then I want to stamp the time for the ship, and that's because I need to know if I have to switch, I need to know how long has it been working on this. By the way, this should, yeah, okay. I stamp the time on the ship, and then I add it to the berth. So notice that here, what I've done is the ship has now, I've popped the ship off the queue and I've added it to the berths. All right, what else could change the number in the queue, whoever's in the queue? And that's this event here, start unloading with 1 crane. So again, notice I'm not treating this like a flow chart. I'm looking at what the state transitions are. So if let's say if I start unloading with 1 crane, then again I pop it off the queue. I get the delay in queue as the elapsed time, and just as before, I need to stamp the time and add it to the berth. In fact, if you look, the state transitions for starting and loading with 1 crane and starting and loading with 2 cranes are different. Are the same. What is different? What's different is going to be in the scheduling edge, and we'll see that once we finish with the events.
All right, question real quick.
Yeah.
So the R is the time remaining. S.R.
Oh yes, yeah. Thanks for R is the.
Okay, so R is not an entity. R is something you will add to ship.
Yeah. Notice the syntax. It's S.R. So I mean, and again that would be.
Okay, I see it.
R. That's what that is. Yeah. Thanks for pointing that out. I should have said that. Oops. Okay. Okay. Well, and then just kind of peeking ahead a little bit. The idea is that if we start unloading on 2 cranes, then the delay is going to be the remaining time divided by 2. Whereas if I start unloading with 1 crane, the delay is going to be just the remaining time. Okay, let's go back to the events here. So there are 2 conditions under which I would start unloading with 1 crane. One is that it had been unloading when I show up, there had been just 1 ship in the berths. And if there were, that means that both cranes were working on it. And so in that case, and how do I know what that is? If the size of the berth container is 1. If the berth container is exactly 1, then that means that there's exactly 1 ship there, and that means that it's being unloaded with 2 cranes. In that situation, I need to switch to 1 crane. So what do I do in that case? Well, first I got to get the ship that's there, and you know, I can get the first one if it's like a sorted set or something. And since it has been working with 2 cranes, I credit the work at twice the rate. And then I stamp the time again because that's going to be, well, it's a little bit redundant, but let's see, was it? Well, no, I need to stamp the time here as well, just because I'm saying, okay, I've worked at twice the speed now, and then now I'm going to be working at 1 time the speed. So I'm going to stamp that here so that if I have to credit it later, then I know to do that. Now,
Arnie,
so
sorry,
yes.
on that, so that those timestamps, I guess, is that just in the method of get remaining unload time that it will calculate the amount of time that's remaining?
Not from the stamp time. It'll calculate it if I invoke work.
So if you put work on there, it'll, from whatever point, what is work? What is that 2 multiplying by? Wouldn't it be the stamp time minus the last stamp time?
Yeah, pretty much. When I say work at a given rate, it decrements the remaining unloading time by the elapsed time
Okay, sorry.
times the rate.
Sorry, you got a lot going on. I'm just trying to fuck with you.
Yeah. Yeah, no, these are great questions. Okay, and the reason I have to keep doing it because when I stamp the time on a ship, I'm saying, okay, now I'm beginning work at a particular rate. So, and this is okay. I'll have to come back to that. But okay, I've done arrival, start. Let's just kind of look at if a ship kind of comes in and is the only ship, and then it leaves before anything else comes in. Then I finish unloading with 2 cranes. And what do I do then? I pop the ship off the berths, and then now to compute the total time, because I can't use the time stamp. And I could if I wanted to, I could have defined another variable in the ship, but instead I'm just going to use the age. In other words, the age is the time, the amount of time since when the entity was instantiated to what the current time is. So every time I instantiate an entity, it saves what's called the creation time. And so age is just the current sim time minus the creation time. And so I can just kind of call that. So and this is important to kind of notice. If I finish unloading with 2 cranes, then the only way that can happen is if there's no other ship waiting and there's no other ship in the berth. So notice that end unloading 2 cranes does not schedule any other event. That's because if I finish unloading with 2 cranes, then when I'm done with that, there's nothing more, there's no other event to schedule. There's nothing to be done. So notice that there are 2 scheduling edges and 1 canceling edge coming into this, but this doesn't schedule anything. And that's kind of the way it is. So this sequence of events, say arrival, start unloading 2 cranes, end unloading 2 cranes, if that happens in sequence, the only way that can happen is if a ship shows up to an empty harbor, gets all unloaded, and then leaves before any other ship shows up. And that's a possibility. So this sequence of events, again, it's not, don't think of this as a flow chart, but this sequence of events would only happen if the ship were unloaded with both cranes and done and out of there before any other ship showed up. Okay, the complication is all in these other ones. And say if I have to switch, let's look at the other 2 events here. Now, see, if I have if I'm switching from 2 cranes to 1 crane, then first, just sort of making a mental note, that end unloading of 2 cranes is on the event list, so I need to cancel that. But after this, I need to make sure that there are going to be 2 end unloadings of 1 crane on the event list. And the terminology can be a little confusing, and the how shall I put it? I can make it confusing one way, or I can make it confusing another way. So I've chosen to make it confusing one way. No matter what I do, it's going to be a little confusing. So let's take a look at that. So here's, well, again, end unloading. What is it going to do? I'm going to notice I'm passing the ship. So when I say end unloading with 1 crane on the ship, I need to say which ship it is. See, when I end unloading on 2 cranes, I don't need to know what ship it is because there's only 1. But here, if I'm working with 2 cranes, or 1 crane on each ship, then when I finish unloading, I need to know which ship it is. And so I need to pass that as an argument. And so what I'll do is I'll remove it from the berths. And again, I can compute its age here. Okay, now finally, what could happen? There are 2 possibilities. Either there's another ship waiting, in which case that ship needs to come in and start unloading with 1 crane. Or what do I do if I finish unloading with 1 and there's nothing else waiting? In other words, if the queue is empty. Well, if that's the case, then I need to switch to 2 cranes. Okay, so now I'm switching from 1 to 2, but only in the case where I finish unloading with 1 crane and there's no ship waiting. And the state transition for there is, again, I need to find the ship and get the first one. There's only 1 there, but that's okay. I need to credit the work. See, every time I switch, I need to credit the work. Now I've been unloading at rate 1 on this ship. And so I credited that work at a rate of 1. And then I stamp the time again because I'm about to work at twice the rate. Again, notice the delay here is going to be twice. But then in addition to that, I have to remember that for that ship that was operating with 1 crane, there was an end unloading with 1 crane on the event list. So I need to cancel that one and pass it as an argument, the ship that was left. Okay, so that handles the the state transitions. Now let's look at the scheduling and notice the canceling edges. So this is an exercise in passing arguments, using containers, and canceling. Okay, so let's look at our events one at a time and see what events they need to schedule. So, I mean, at this point, if in developing the model, I would now just have nothing but the circles. I would just have the events. Okay, so when a ship arrives, there are two possibilities. Well, actually three. First, if the berth is empty, that is, remember that this B, this occupied berths, that's a container. So if that's empty, that means there are no ships there. And that means I can start unloading with 2 cranes. Or if there's exactly 1 ship, then I need to switch it to 1 crane. Okay, so if a ship shows up, there's 1 ship in the berth, that means that it had been working at a double rate, but now it needs to switch back to 1. And so if that's the case, then I'll schedule that. What is the other possibility? The only other possibility is that the size of B is 2. And if that, notice that there's no scheduling edge for that. What that means is if there are 2 ships in the berths, then there's no room at the end. And so I have to wait in the queue. In other words, I'm not going to schedule anything. Okay, let's take the easy one. If I start unloading with 2 cranes, then I'm working at twice the rate. So remember, R is the remaining time. Thank you for pointing that out. But if that's the remaining time, the amount of time it's going to take me, though, because I'm working with 2 cranes, is half that. So the delay is going to be the remaining time divided by 2. And this is where this 2, and again, the 2 probably would be better. I mean, the next iteration of this model, which we're not going to do, that would be a parameter, because it's kind of optimistic to think that the cranes would automatically work twice as fast. They would certainly work faster, but twice as fast, that's the best that you can hope for. Okay, so but that's all I need for that. Now let's look at what this is. Let's see. Again, end unloading of 2 cranes. Again, nothing to be scheduled. It's the switching ones that become challenging. Let me do this one first. So when I switch from 1 crane to 2 cranes, again, what is that could schedule that? If I finish unloading with 1 crane and there's nobody in the queue. So again, we have that, but I'll have to come back to this event. Well, actually, let's do this. Yeah, so if the queue is empty, then I'm going to schedule this switch. If it's not empty, then I need to just schedule another 1 crane. So this edge. This is what we've been dealing with the multiple server queue up to now. So this should be fairly understood. This, however, this is the new one. So if the queue is empty, though, then I need to switch. All right, let's look at when I switch to 2 cranes, then what do I need to do? First, I need to cancel the end unloading that I had for that ship. There's 1 ship left. and remember, I've kind of figured out who it is. I'm not popping it because if I pop it, I remove it from the berth, and it's the ship. This is the ship that's left. It's not going anywhere. So I can't pop it, but I do need to sort of peek at it. But for that ship, I need to cancel its end unloading with 1 crane. And again, I pass the ship as the argument, and that should cancel it. And then what else do now that I've started to work on it at twice the rate, then I can schedule this unloading at where the delay, the remaining time is cut in half. And this remaining time has been updated by the work, remember. So I've credited the work that I've done at a rate of 1. And now whatever is remaining is going to be, has to be divided by 2. Okay, so let's see, did we do this? All right, let's look at this switch to 1 crane. That's one of the more complicated ones. That's probably the most, well, actually, here, when I start unloading with 1 crane, then I just schedule an end unloading on that ship that I popped off at a regular rate. Okay, that's an easy one. This is really the toughest event of the whole thing. All right, so let's look. This is the case where a ship has arrived while there's exactly one in the berth, which means that it had been working on with 2 cranes. Therefore, there would be an end unload of 2 cranes on the event list, and I need to cancel that. Because if I don't cancel that, then it's not going to be good. Right now, having canceled it, I'm now in a situation where I have the ship that showed up and the ship that was there. Okay, so this scheduling edge is for the ship. Let me get rid of some of this other stuff. Come on. Come on. Okay, this scheduling edge says, okay, now notice I've credited the work. This scheduling edge says for the ship that was already in the berth, I need to now schedule its end unloading with 1 crane, and I'm passing it the guy who is again first. I can't pop it. I have to just look at it. And the delay is a standard rate, and I schedule the end unloading of 1 crane. But for the one that just arrived, I need to get it off the queue. I need to get it off the queue and also schedule it. So notice that I also schedule unconditionally that I'm going to start unloading with 1 crane. And for that, I do pop it off the queue. For that arriving ship, I have an elapsed time. Again, I stamp its time because now I'm going to be working at a unit speed, and I now add them to the berth. So now at this point, the berth B has 2 ships in it. And then I schedule another end unloading 1 crane passing it this ship. So notice that I'm using S here and S here. These are 2 different ships. This S is the ship that was in the berth. This S is the ship that was being popped off the queue. Okay, and that is the event graph in all of its wonderful glory. And now notice that, just one little thing, notice that I have just arrival, but just to be cantankerous, when I'm defining the ship arrival process, I called it ship arrival. So what that means is that I can't just use a plain old listener, I need to use an adapter. In other words, I need to adapt ship arrival to arrival in order to make it work. Okay, that's just sort of another. Now, I could have, if I'd simply called this arrival, then I could have just done a listener. Then I could have just said, okay, just listen. Okay, but I didn't, just to show that you can either use an adapter, which just deals with one event, or just listen to everything. Okay, so that is this model. And I see that I've managed to take the whole time. And so if there's no other questions, I will see you tomorrow. And again, for tomorrow, there is nothing scheduled, but I will be there to answer questions or anything that's coming up about the project.
Professor Buss, I had a couple questions about the why we were stamping time in specific places here, vice how we looked at it yesterday and the CPU component event graph.
Yeah.
So yesterday we stamped it at join queue, which was the first event, and here we're stamping it at, let me see if I can pull them both up, arrival, which is the first event. I guess looking at just today's, I'm kind of perplexed why we like for start unload 2 cranes, just looking at just those 2 events. Why D, that delay in queue, why it couldn't just be s dot age, because in that finite event there, that I thought that would give you the delay in queue so far.
Yeah, you're correct. That is, if we said age here instead of elapsed, then that would give the same number. Yes.
So then if we had that, I don't know if we would need the s dot stamp time for arrival. We would, because we would still have this s dot stamp time for start unload. I guess, is it?
Yeah, no, actually, no, you make that. That's a very insightful point, and you're absolutely correct.
Okay.
In other words, the only reason we're stamping time here, well, there are actually 2 reasons, but one reason is that the timestamp is actually the primary comparator key on these entities. So when I'm adding it to a sorted set, that just makes sure that the entities that were time-stamped earlier show up higher up in the queue.
Okay, so is that first timestamp then? Is that how birth first? Is that how that's working? And that's why we need it at arrival?
Actually, not in this particular case, not really, because see over here, this first is it just that's the there's only one ship in the container at this point. So first, last, whatever. It just at first is just the most convenient way to actually get a reference to it.
Okay.
Because in the bursts, it actually doesn't matter what order they're in. To be honest, but just to kind of emphasize your other point, the only the other thing about timestamp is that when an entity is instantiated, the timestamp and its creation time are actually both the same. It stamps the time when it's created. So you're absolutely correct that if I use the age instead of the elapsed time for all of these delays, then I can do away with this stamp time here. You're absolutely correct about that, and then that's insightful.
Okay.
The other times I need to stamp them so that I can figure out, so I can correctly show how much time I've worked on them. In other words, work uses the timestamp to say this is how long you've worked at it at this rate. Okay, does that answer it? But yeah, that was a very insightful comment.